Hello everyone, welcome to another Jura video, and in this one we are going to be implementing variables. And I was thinking about what our variable assignment syntax should look like, because it's very important. The way that your language is perceived is very dependent on your variable syntax. Because if you put the types on the left, like this, you're not very cool. You're very old-fashioned. This is what is this? C? What is this? Java? C++? Ugh. But if you put your types on the right, despite the fact that you had to type more characters for the same amount of information, you're perceived as very cool. And this is your Rust, this is your Jai, this is your, I think, Odin? Although Odin... Let's see. How does Odin do it? Yeah, look at that. On the right. Cool language. Okay, so I want Jura to be cool, so I'm going to put the types on the right. And I'm going to use this syntax because it seems to be in vogue, but also it gives you one other advantage, which is if you imply the type by having the assignment on the right, or by any other means, you don't have to actually say what the type is. And then you get this cool emergent syntax where the colon and the equals are two separate tokens, but you can write them like this, and it looks like, what's the language? Does Pascal? Is that how Pascal does it? Hang on. Let's see, give me some examples. No, Pascal... kind of. Not really. I can't remember what language it is that has the colon equals as like its actual assignment. Maybe Lua? Nope. I don't know what I'm talking about. But you basically get this syntax for free. And then if you want to, for like mutability, like I kind of like the idea of this kind of borrowing some features from Rust. Like, Rust has some really nice syntax features. The problem is that if you want to use them, you have to use Rust. And you don't always want to use Rust. Sometimes you just want the garbage collector to think for you. And that's what Jura is going to be. And Rust has some really nice stuff around mutability, where by default it's mutable. So you could do something like this, like Jai, where instead of equals you use colon. And then when you get rid of the type, you end up with this cool like double colon syntax. Which is cool, but it isn't exactly the default. So I think, you know, maybe we have this, maybe a mute keyword. No, that looks disgusting. Let's not worry about mutability for now. Let's just have this syntax. So let's have an int x1, int y2, and let's print x plus y. So I think this is going to be a fun thing to compile. In fact, let's not actually worry about the implicit stuff first. Let's just get this to compile. Because this is going to add a bunch of features to our language all in one go. Like variable declaration, then assignment, and then maybe we want to reassign the x after we print it, and then we want to print it again. We could do all sorts of things. Because this, I think, is technically a binary expression, the way you parse it, but I don't really want to think about that right now. So let's just compile this. So what is this doing that we don't have? First of all, let's add in let's see, is it this? Yeah, this is the one. We want to add, let's add them here. We have two types so far. Don't love how that looks. What if we put them with true and false? What does that look like? That is pretty good. I think we want to move true and false to that pink one. then we can say b bool is true. Oh yeah, then that looks like an int literal, sort of. It's kind of a different shade of teal, but close enough. Anyway, but bike shedding. We're not programming. What are we missing? So we're missing this token, and this being a special kind of like identifier, I suppose. And it's going to add a bunch of stuff to our language, like scopes. Like if I was to do this shouldn't compile because X isn't in the scope when we print it. So this is going to be a very meaty topic, and it's probably going to take me the course of a couple of sessions, all put into one video, but by the end of this, we should have this compile, we should have reassignment, maybe constants, scopes, yeah, all good stuff. So, let's move this over to the side so we know what it is we're actually compiling towards. Let's close all of this. And now we've ruined the fact that we put that to the side. Let's go to our token kind, enum. There we go. So we need a colon. Let's put that near semicolon. And we need an equals. Let's put that here. Why not? There we go. 2 new tokens. So let's add them here. So we want colon, and we want an equals. So what actually is this? Well, this is a statement, right? This is a whole arse statement. So we should go into our parser, wherever the hell it is. Here it is. And what are we doing here, man? There we go. When we're parsing a statement, we already kind of have a case where... Oh, no, we don't. How do we parse the method calls? Here. So when we're parsing an expression... Yeah, this might break printing. For now, let's say case identifier. And then we should say if... Well, first of all, we need to yoink the identifier. Identit. There we go. And then we just say if peak get kind. What are we peaking? The token. Oh, we already get the token kind. So I can't remember how to program. If we peak and is equal to token kind colon, we're parsing a variable assignment. Otherwise, we kind of want to default to this, but we've already taken this token, so I think we want to backtrack and say we go back and we return an expression statement. So if here, let's say I throw a new, what was it, not yet? It's from Apache. Let's just do another illegal state, to do. So if I try to compile, what do we have at the moment? While. Let's not do that one because that one has an infinite loop. Let's try to do if, because this has prints in it. So let's try to compile if. Still compiles. Prints 10. which isn't correct, saying that 10 is less than 3. So what have I broken? If 3 minus 10 does not equal 0. Ah. Yeah. Okay. It's because in my lower I need to if instead of if 0 is there a let's see, we're doing if ec, we want if le, because we want it to be, or we want it to be, yeah, if le, because if it's less than or equal to 0 so if less than or equal 0. Let's rename this to if equals 0. So if less than or equal to 0, less than or equal to 0, then kind of the same here. Because then here we do if le on this one. So if you do that, be gone. We want that one. If we do that, we get 7, which is, that's false, is this one. Okay, we fixed it. But also, more importantly, we can still print. Okay? Because if I go back to the parser and I remove this peak, you know, and we just do, you know, if we didn't have this peak and we just said, oh, expect a semicolon, expect a token, expect a token kind colon, right? And we didn't do any of this. We just yield null for now. And we try to do while, we get an error, which is expected a colon but got open paren, because we broke method calls. So we need to have it do this, which is kind of disgusting, but hey. So if we get that, we get a colon. And let's always expect the type identifier for now to do make this optional. And then we're also always going to expect a equals. Like so. And then we need an expression, which is our initializer, which is going to be this. So we're always going to have an initializer and we're always going to have a type identifier. In future, if we have an initializer, we don't need the type identifier. If we don't have the type identifier, we should require that there is an initializer. Yeah, cool. And then we should expect a semicolon. Because it's a statement. Yes. Okay. So if we have all that, we should yield a new variable declaration statement with an identifier, colon, a type identifier, an equals, an initializer, and a semicolon. Wowee. So, new statement. New statement just dropped. Not a C variable declaration. We're not interrupting with C. Extends statement. Now we do our classic song and dance of all of this. Hello. My arrow keys stopped working. Cool. And then we need our constructor. Okay, this is getting a little ridiculous. Let's make some room. Good lord. Look at that. And then the span is from the identifier to the semicolon. And this is important because no matter what, even after you make some of these optional, there will always be an identifier and there will always be a semicolon. So that span is always going to be fine. We actually don't use the spans for anything yet, funny enough. So we want that, we want the type identifier, and we want the initializer. Everything else doesn't really matter. In fact, we don't even need to save it. But we probably should. Otherwise that breaks all of that. Cool. So now our type checker is going to complain. And we're going to have a lot of stuff to do in the type checker actually. Let's get rid of that so we have a bit more room. Get rid of this, we have a bit more room. So we have a brand new statement. The first thing we probably want to do is to type check the initializer. Because we want to make sure that that matches the type that we said it was going to be. I know I just closed it, but if we open it back up, if I said, oh, y is an int, which is true, we're going to check this, figure out that this is a boolean, and then we're going to check that and say, well, you said it was a boolean, and it isn't. To be fair, we could do it in either order, but I decided to do it this way. And then we also need a method that takes an identifier and tells me what Jura type that identifier is trying to be. So, Jura type equals parse type of the variable declaration statement type identifier. And then we're going to create that method. Is that how we're going to do it? Maybe, because this might not work once we have more complicated type like expressions, not expressions, but like currently we just have this, right? Later down the line we might say, oh, y is an int array of an array of an array, and that kind of requires you to have recursion in how you parse this, but I'm not going to worry about it yet. But I'll say to do this won't work for complex types like arrays which need recursion. For now we just say return switch type identifier get text, and then we say case int is Jura type. That's not how we do that. Is int type instance. Case bool is bool type instance. And then you don't really have a void type. So then by default we shall throw a new illegal state and say unknown type blah. I really do need to get to do proper errors at some point. So let me just yoink that out so I can reuse it. Like so. So now we have the Jura type, and then we say if Jura type, let's just call this type. If type equals initializer get type, rather if it doesn't equal, throw new illegal state, and this will be type mismatch expected blah but got blah. And really that should be its own function, because once we start doing assignment and everything, we're going to need to do this a lot. But this is going to, we expected type, but we got the initializer type. Fantastic. We have correctly set up our types. Now we need to create a variable in the type checker for it to be able to load later when we reference the variable. So we need a private final map of string to variable. With variables. So let's make, I think it can be top level, but let's see. No, let's make, because I can preempt this, a scopes package with a variable class. What does a variable have? It has a name, it has a Jura type, it has a mutability, and I think that's it. None of these can change, so I think this can be a record. Mutable. There we go. So yeah, we have that. When we create a new type checker, we create a new map of variables. Now, when we get to scopes, we're going to need to wrap this variable map in a scope, because you can have variables inside one scope and variables out in an outer scope, and they may shadow each other, but you don't want to overwrite them. Assuming we want shadowing, maybe we don't yet. So, once we have that, we need to say, actually the very first thing we should probably say is if variables contains the key, variable declaration statement, get identifier, get text, that's very wordy, let's save that to identifier. If it contains the key identifier, throw new illegal state exception, variable blah is already defined in scope. Cool. Now we know that it is not in the scope. So we can say variable equals new variable. So we can just say, oh, we can just say var variable. Oh, I was going to say var, but it's not going to let me do that, is it? It does, because it's a new keyword. But let's not do that, that's silly. The name is the identifier, the type is the type, and the mutability is true. And then we just say variables, put, identifier, variable. Cool. And then we just need to yield new typed variable declaration statement. And what does this have? This has the variable and the initializer. And that's kind of it. Easy peasy. So give it all of this. Yep. Give it the constructor. Do all of this. Do all of this. And that. Cool. Now our lowerer is going to complain. And I don't think we want to change anything. So it's going to be such a long class name. There we go. And this is just basically going to have all the same stuff. And then the lowerer, We see this. Get a typed variable declaration expression. Let's just call that that. And then we just say a new lowered variable declaration statement. Variable declaration state variable. Get initializer. Wrap it in a list. There we go. So now it's happy. So now we need to omit it. So how do we omit a variable declaration? First of all, we should omit the like this. We should omit the initializer, and then we should just store it. Visit. What is it? Is it just an instruction? So we just want to do an iStore. Yeah, and we need to do it to an index. Let's not care about that right now. Let's just do iStore 0. Do we not have iStore 0? So does it have to be an int instruction? Probably. And then it is opcode operand 0. We should to do calculate index properly. That's kind of it, I think. So if I go back to our this and compile variables Jura, and if I get rid of this, because we don't have variable expressions yet, they should be very easy to write. But now, if I compile it and look at main, it thinks it's a Boolean because it's only 1. But if I go back to this and I say this is actually 123, and I compile it, still says it's a Boolean. Did I fuck up this? iStore operand. Yeah, we should be popping the value off the top. We omit, we iStore into operand 0, which is the index. Yeah. Yeah. Did I not save? Interesting. Why is it doing that? I must be doing this wrong. But it's saying it's true. iStore. Is it SIStore? BIStore? No, it's just iStore. Stores an int value into variable index. Huh? Okay. Give me a moment. I'm gonna debug this and I'm gonna find out what the hell is up with this. Okay. It's a little time later. I now have a thinking beer. And it turns out there were two problems. First of all, this needs to be a var instruction, not an int instruction. Sure, why not? The second is, so I have this, which is then going to get the print stream, load that variable back out, and then print it. And as you can see, it's now correctly assigning it 3, and then it's going to print it. But, this again, but if I get rid of the use of the variable, there's some sort of optimization. where it just doesn't care about the value. So that's the problem. Okay, but that's fine. That is just fine. So let's move on. So we've now got storing. We don't store the index properly, but we'll deal with that later. So now let's try and actually print the variable. So as you can see, methods other than print are not yet implemented, because we have an identifier in a expression. And this is before we even try and get the open paren. So if I instead did this check after we've gotten the parentheses, which is probably what we should be doing, the error should instead say we expected an open paren, but we've got a close paren. So we basically need to peek. If not peek equals token kind open paren, this is probably a variable. So we want to just yield new variable expression with the, what is it? With the token. That's it. We do this dance. There we go. And then the span is just the token span, and let's do a helper, get text, like so. So now we have a variable expression. So now our type checker needs to know how to handle that. Down here. So this should be very easy. So first of all, we just need to say if variables contains key the text. That's all good. So we want to check if it doesn't contain it. Otherwise, throw a new legal state. No such variable blah in scope. And then we want to format that with the text. If we get it, we just want to say variables get text is our variable, and because it's funny, let's do that. And then we just yield new typed variable expression with the variable, not all the variables, but the variable. And let's make it. I swear half of this is just watching me create types like this. Do that, do that, create the constructor, create a field, and then a getter, and then the type is the variable type. Boom. Lower doesn't need that, so now bytecode emitter. Brand new expression. So for this one, we want to visit a var instruction, iLoad 0. We do want to do more than that eventually, but for now that should compile, and it prints 3. We have a variable. We can now assign 34 to it, and do that. Cool. So we can now have a second variable, an int, and we can make that 4. So we print x, and let's print y, and this won't work. It will print 4 twice. You know why? Because we overwrote it. if we go to main, see? We do a store twice. And because we never use this one, it, for whatever reason, doesn't assign it properly. So, we need to correctly know which variable index a given variable is referring to. And I think this is fine. Every time we define a variable, we insert it into this map. And maybe not. Maybe we have a list? No, because that will break. Let's do this. Let's see where this takes us, and then we can fix it later. So when we create a variable, let's do variables put variable declaration statement, get variable name. I think we should take that out and do var because it's funny. Put variable name, and then we should do variables size as the index. So let's do this and then that. Does that feel okay? Because we're only ever going to increase. We're never going to decrease this. We'll only decrease it when we come out of the scope, and then we just remove the hash map entirely. So maybe a list is fine. Yeah, maybe a list is fine. So let's do this. And we just add it. Like so. Yes, we want to save the whole variable because we'll need the type later as well. So get the index, we add that, we store it at the index, we calculate that properly. And then here we want to get the variable, and we want to, actually it doesn't matter if we store the whole variable or not. Because we have access to it here and we have the type here as well. Oh well, doesn't matter. And then we just say load it at variables index of variable. And because this is a record, we get a good equals for free. So let's compile that. There we go. Now we have two variables. And you see, interesting. It says the first one is var2 and the second one is var1. If I had a third variable, z, set it to 5, print z, does it do them in reverse order? Does them in a weird order. Whatever, it works. I'm not going to question the compiler. It prints them in the right order. And we can do stuff like this with them, because it's just expressions. Yep, that's correct. Variables. Okay, so that's all well and good. But if we were to do this, technically that shouldn't compile, because we've defined x in an inner scope that we don't have access to out here. However, if we compile that, it still works, because if we look at what that decompiles to, we kind of erase the scopes. And okay, maybe I lied about we never decrease the number of variables. So let's try and implement this. So let's see where this takes us. inside the type checker, we need to have a scope. So let's create that. And look at that, we even have the scopes package from earlier. So let's create a scope. So what does the scope have? Well, it has this map of variables. So we'll create that in here. It also has potentially a parent. So if we create these, we probably don't want to do it like that. We want this with a new hash map, and we want an empty constructor that calls null. And this is the global scope, this one. So maybe it'll be useful to have a is global scope, but let's have get variable get parent. Actually, we probably don't want to do this. We want to do get variable, something like that, with a name, and just do that. And we also want to do what would it be? Declare variable. Like that. And we just say variables put variable name variable. However, here's where things get a bit weird, because in our type checker, we're doing this. So let's get rid of that and say if we declare it, oops, like so, then we throw an exception. Now, maybe that's not how we want to do it, and maybe we want to return like some sort of result, like you know, a diagnostic. But for now, an exception is fine. And we also want to yoink this one from here. There we go. However, that's also not everything, because imagine, if you will, we had a situation like this. This is valid because we're referencing X, which is in an outer scope, in an inner scope, which is fine. We're allowed to do that. But if we do it like this, we're only checking the, not there, in here, we're only checking the current variables. So what we want to do is save the variable, var. If the variable is null, i.e. we didn't find it, and our parent is not null, return parent, get variable, name. We search in our parent scope for this variable, and then that will, if that doesn't find it, it will search in its parent scope, and so on, until we get to here. So we looked in our variables, we didn't find it, but we have a parent, so we ask the parent, hey, do you have this variable? We come in, we get it, we don't have it, but this is the global scope. So we fall out here. So I think here we say if the variable is null, we haven't found it. Maybe we can do it more smartly by breaking this into two. And then we say that. I would like some braces, please. Otherwise, we return the variable. I like that. So if the variable is null, and we have a parent, ask the parent. Comes in. Do we have the variable? No. Oh, with a global scope, throw. Otherwise, if the variable isn't null, return it. I dig it. Okay, and we have one too many braces, I believe. There we go. Cool. So, here we come to the usage. So let's say we have a private not final scope. When we create a new type checker, we create a new global scope. Very cool. When we come to declare a variable, we say scope, declare variable, and it handles it for us. When we want to get the variable, we ask the scope to get the variable. So now, this should compile. Cool. But there we go. This should not compile. I am a fool. Do you know why it didn't not compile? Because we never actually created a new scope. So let's go back to the type checker. When do we want to make a new scope? Well, when we have a block statement. So we need to say scope equals a new scope, passing in the current scope as the parent. And then we check all of the type statements. Well, we type check all of the statements. Once we've done that, we set the current scope back to the parent. Make sense? And now compilation fails because there is no such variable x in the scope. But if we remove the braces, it compiles. And if we move this print into its own scope, it still compiles, because these variables we're referencing exist in the parent scope. And we can do this as many times as we want, because we recursively go through all of the parents and check. So that's great. And that means if I go back to, or if I, in this example, if I say if x is less than 5, print x, that should work. Yeah. Phew. Okay, my programming language works. Also, my camera is a bit low today. There we go. If we do that, if it is less than 5, which is true, let's say w, which is an int, equals 10. And then we try and print w out here. This should not compile, because there's no such variable w in scope. However, nothing in our parser says that an if statement has to be, the body has to be a block. We just say it has to be a statement. So this is valid. And not only is it valid, but this is in the scope. And I don't know if Java bytecode allows this. Look at that. It's allocated it outside of the if for us, and then assigned it in the if. And you know this is bad, because if this is false, what the hell do we have in W? Well, I didn't like that. I think because, yeah, for that very reason, we don't have enough information to say what W is. So I think what we need to say is when we have an if and we have the body, we should create a scope for it implicitly. So let's do that. So when we go into our type checker, and we're type checking a statement, for the if statement, we should do this around type checking the body. So even though we don't say we must have a block, we have created a scope, which I think is good. It'll protect us from leaking those sorts of definitions. And then we should do the same for else. So clean this up. Yep, and then do that around the else. And we should do that around the while. It would be nice if you could like do some sort of try with resources shenanigans in Java to like automatically handle the scope resetting for you, but I don't think you can because you're mutating the thing that you're trying to try with resource, you know? So I don't think that'll work. But there we go. We have scopes. And I don't think it really matters that we're constantly incrementing the variable. So if I, what have I done? Yeah, I'm still trying to print W. So do that. All good. Yeah, and then because we aren't actually setting the variable, or we aren't doing anything with the variable, we don't set it to anything useful. Cool. Yeah, because we're never actually decrementing the variable counter, I think that's fine. We're just constantly increasing the number of variables we have. That's fine for now. Which means we can go back to this. Max locals, I think, is just that. Yeah, happy with that. If I set it to 0, does it complain? Okay, it doesn't complain, but what if I run it? What am I telling it to do? I'm telling it to compute the frames. Interesting. I don't really know why that doesn't break it, but I'm not going to question it, and I'm pretty sure that this is the correct thing to put in. But hey, we'll leave it as is for now. If we get an exception later, we'll handle it. So we've got variable assignments. Well, variable declarations. Let's do variable assignments. So let's say instead of this nonsense, if it's less than 5, we set it to 5. And this is pretty interesting. How are we going to, well, first of all, parse this? Because what we can do is look ahead for an equals and try to see if it's an equals, and then try to parse an expression. But you can do something like this in Java, I'm pretty sure, and you get this as the return of the assignment. And I kind of like that. That's been handy sometimes, to be able to assign and then use the value of the assignment after you do that in one go. So this is basically a binary expression, and you can kind of do sick shit like this. You know? So I think we should handle it like a binary expression and see where that takes us. So let's try that. So we actually have all the tokens we need for this. It's just going to complain that it doesn't expect it. Yeah. Why do you expect a semicolon, my friend? Because we're parsing a binary expression. And, importantly, equals has no precedence. So if we go into the token, the token kind, we come into this default where there is no precedence. I think equals should be even lower than the others. So let's bump all of these up. And you know what? It's kind of annoying bumping these up. So let's leave us some room for next time. So equals should be the lowest precedence operator, because we should resolve everything else and then say equals. And we're going to start getting into some interesting concepts here, like L values and R values, but we'll get to that when we get to that. So now it should complain that we don't know what the binary operator is. Operator null. Oh, we actually don't have any checking to see if we actually got an operator. So we parse the binary expression, we come into here, we get the precedence. The precedence is an interesting value. We try to parse the binary op. Here's my good friend null again. What I eventually want to do is I want to have my own exception, which is like a compiler exception. And if that ever gets thrown, there's a bug in the compiler. It should never get thrown ever. All of the other errors should be errors in input, in the like in the compilation. Well, there should be diagnostics in the compilation. There shouldn't be exceptions. Whereas if we hit one of these, we should stop and say your compiler is broken. Something has not been handled. But until then, you know what? Let me be the change I want to see. Let's call this a compilation exception. And it's a runtime exception. And we want to... God damn it, how do I do this? I just want the menu. Give me Alt Insert, sure. I don't have that on my keyboard. God damn. We want to override, I think just that one. We don't care about the others. So here, we throw a new compilation exception. Unhandled binary operator for token blah. It's just kind. So now, if we do this, we actually get something interesting. We get a compilation exception. Unhandled binary operator for token equals. And let me actually just put that in something to show that it's a variable. There we go. Here we are. So case equals. This is the binary op assign. So now we're going to get another complaint. Operator assign is not applicable between int and int. Well, sounds like we need to add some special handling. If op equals binary op assign. I was looking for equals. If left equals right, rear, then we want to return a new typed binary op of left, op, right, left. I want to say to do more sophisticated, because we want to be able to like assign something like an int to a float. That should make sense. But assigning a float to an int, maybe that should require an explicit cast to say, hey, if you're happy with the fact you're going to lose precision, do that manually. Otherwise, we're going to stop you. Whereas going from an int to a float, you don't lose any information. So more sophisticated type coercion. Is that how you spell coercion? It's with a C. Cool. Unhandled binary op assign. So this should be a compilation exception. Ooh. So here's where we get to something interesting. If I go to the type checker, wherever it is, there it is. So we're checking a binary expression. We get the op. If the op equals, what are you? Binary op. Assign. If LHS is L value. Here we go. This is probably something that we want on here on the expression. So we want to say public boolean is L value false, and only certain expressions are L values. And currently the only one we have, or the only two we have, are variables, which are L values. So we want to override boolean is L value. True. And because we want to do this sort of binary expression chaining, we only want to assign, or we only want to say that a binary expression is an L value if its left-hand side is an L value. Is that true? If its right-hand side is an L value. If it's right-hand side. Because if we say x plus 3 equals 4, that doesn't make any sense. But if we say 3 plus x equals 4, that kind of makes sense. So let's try that and see where that takes us. Because then we would assign 4 to x and then add that to 3. So we've done the assignment and then we do the addition based on the result of that assignment. Make sense? So if the LHS is not an L value, throw new legal state. So now every time I throw an illegal state exception, I want to replace that with a diagnostic. If it's a compiler exception, I want to keep it there because you should never see those in the real world. Cannot assign to non-L value expression, blah. To format that with binary expression, LHS, yeah. And that'll tell me what it is. Okay. Where did we get to? Unhandled binary op assign, and that's a compilation exception. There we go. So now we're here. So now we know that the left-hand side is a that it is a assignment. So I think actually I do want to omit that differently. So if the binary expression get op equals assign, we want to yield emit. Let's do it inline for now. So we want to what do we want to do? Because if we have the LHS and it's a variable, we can just we could do something like that. It's like if binary expression get LHS instance of typed variable expression. That's very easy to handle. Yeah, we might have to have two separate cases, one where it's a variable and one where it's a binary. And then later on we might need to handle separately array indexing. Because if you say like array index 0 equals, you need to do some hoops jumping to assign there. So we might need to have a separate variable, a separate function. So let's say we want to load that. So let's say, yeah, we just want to store. So we want to emit the RHS, and then we want to say mv visit var instruction istore. Then we get the variable. So int index equals variables index of that. And also, this shouldn't always be an istore, because we could be storing a different type. But for now, every type we have fits in an integer, or at least is castable to an integer without losing information. So that's okay. And then return. So we don't do the rest. That's kind of scuffed. And it doesn't like it. Yeah. So what did we do wrong? We come into here, we emit the RHS. What is our RHS? 5. Let's get rid of all this nonsense. Let's do something simple. That doesn't even, it doesn't even like that. Oh, because I got rid of the semicolon. Okay. That it's happy with. If I then reassign x to 5, and try and print that, it's okay with it. Okay. So it was unhappy about that more complicated scenario. So what was it about that one that it didn't like? Because I wasn't printing it? No. So I was happy with this. So we have a binary expression. Left-hand side is x. Right-hand side is I'm an idiot. I'm doing this for every binary expression, not just if it's an assign. Yeah, this is pretty gross. So this, I think, needs to be moved into its own method. So let me break this. And then, oh, I hate you don't put braces around it. And then we move that to emit assignment, and we don't want to return anything from emit assignment. This should be void, and we don't care. So if it's a variable expression, otherwise throw new compiler or compilation exception unhandled L value in assignment, and it is whatever this is, binary expression get LHS, and because we're in here now, I don't feel so bad about doing that, and then we can get the RHS as well. And we know the op because the op is a sign. Cool. Still doesn't like it, huh? Unhandled L value in assignment. typed variable expression. Return. There we go. 12.5. Let's do this. So now it should be 14. Just like that. Hey! Cat. Okay. If you're wondering why I keep making cuts like that, it's because the cat's food is up there so that my dog doesn't eat it. And whenever my cat decides to eat, it's very loud because it's all crunchy biscuits. And so I have to pause and wait for him to finish. But he's done now, and he's out of the room. So, now, let's do this. So, if I've done everything right, which is highly likely that I haven't, there we go, this should complain at the bytecode emitter with a compilation exception saying that I haven't handled binary expression as an L value in assignment. So, how do we do this? So, if the LHS is typed binary, I'll call it the binary LHS. What do we need to do? So, what do we have in this case? Let's do a return and break here. So the binary LHS is variable equals that. Can I recursively emit that assignment? And then emit the RHS. What does this do? I actually genuinely don't know what effect this is going to have. So we come in. It's a binary LHS, so we switch and we get those. LHS is a binary, right hand side is a variable. So we skip, we emit again. We come in, we now have a variable expression. So we emit, return, and it breaks. Unhandled L value. Yeah. What does that even do? Yeah. That doesn't do it all properly. So this emits an assignment. And then we kind of want to load it again and then assign it to the RHS. No. If the RHS is a binary expression. Yeah, it doesn't work. I need to think about this. Okay, I've had to think about this, and I actually don't know how to solve this. And I don't think it's very important right now. So I'm just going to say, if it's an instance of typed binary expression, we just throw for now. And we say it's unhandled. So, this nonsense, not allowed, but this is. That compiles. That returns 14. There we go. And we could also do something like that. Yeah. 13. So that makes x equal to 4. So 4 plus 4 plus 5 is 13. There we go. Cool. Let's actually test this with booleans. So if I say b bool equals true, and I print b, what do I get? I get true. Fantastic. So, all that's left is this syntax. Well, I guess also this, but I don't really want to go into the realm of RAII and how to handle uninitialized variables. So I think we'll just handle this for now. And all of this, I suppose. No, it looks less pretty without the bool, without the types. But anyway, this is going to complain because we expect an identifier but got equals. There we go. We say if peak equals identifier. We do this. So, hello dog. We do that. We do this. So we set that equal to null. Must you do that in my room? Don't know if you can hear him, but he's just scratching himself very loudly. Oi! There we go. I just poked him. I didn't do it. I didn't hurt him or anything, I swear. So, where were we? So if we get the peak identifier, type identifier is null. Cool. So now we simply go to the type checker and we say to variable declaration JSON type equals that. We just say if variable type declaration statement get type identifier blah, 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 does not equal null. Only then we do all of that nonsense. And if we've done all of this, the initializer type is the same as that type, so we can just do that. Now obviously this doesn't work if we don't have an initializer, but we don't care at the moment. There we go. We don't need to say what type it is to assign something to it. Beautiful. And oh, what about this? Okay, we do actually kind of check that, but that's kind of a bad error message. So we just say type mismatch. Expected this fella, but got this fella. And I think we'll also want to throw that. We don't want to just leave it dangling. I think this is kind of gross, so I think we should implement to string on all of these. Yeah. So I think we should force that by saying there is a protected abstract string stringify. So that then forces all of these to implement it. But we should also override public string to string return stringify. So the reason I do it like this is because the subclasses don't have to override to string, but now they do have to override stringify, and that gets used into string. So this is going to complain. This is int, bless you, don't know if you have my dog sneeze. This is bool, and this is unit. And so now we get type mismatch, expected int, but got bool. Perfect. And in fact, we will put those in quotes, so it at least looks like we know where we are instantiating them. There we go. So that's going to look a lot nicer when we have diagnostics, which I think is probably what I'm going to work on next stream, or at least between streams. I don't know how interesting it actually is to implement, but rather than throwing an exception, it would be nice if it just like raises a diagnostic, which is just a type that we can like keep a track of in a list and just keep compiling, and or keep the compilation going. And then once we hit the end, we can just like, if there are any diagnostics, we just print them instead of continuing, and then that way we can just like build up a list of diagnostics, and that can have the span in them, and the span can then point to a location in our code where this actually happened. Because imagine if we had an enormous file, right? Like we kind of already do have a decent amount of code here. We don't know where it actually expected the int but got the bool. Like we can have a look through and we're like, okay, well we put a bool here, but this is it, yes. It's not here. Whereas this we have all the information in the span to say it's here that we expected the bool, or we expected the int but got the bool. Anyway, I think that's been a really productive session, and I'm going to leave it there. So if you made it this far, thank you very much for watching. Leave a comment, like the video, all that good stuff. I should probably say this at the start of the video because statistically you haven't made it this far in the video, but I'm only doing this for fun, not for views. So hey, if you made it this far, thank you very much. I appreciate you, and hopefully I'll see you in the next one. Bye bye.